For the first time in 4 centuries, the universe may stage a breathtaking light show, a dying star's final act. And not just any star, but the fiery giant Betelgeuse, one of our sky's most iconic beacons, could soon explode in a supernova visible from Earth. Nestled in the constellation Orion, Betelgeuse has been acting unusually in recent years, sparking excitement among astronomers. This isn't just speculation, it's a real event that could unfold within our lifetime. So in this video, we'll dive into Betelgeuse's strange behavior, when it might explode, what the explosion will look like, and why this event is so monumental for science and our cosmic perspective. Betelgeuse has long fascinated stargazers. As a red supergiant, it's among the largest stars visible without a telescope. If it sat at the center of our solar system, its fiery edges would stretch past Jupiter. Easily spotted as a reddish-orange dot in Orion's shoulder, Betelgeuse caught global attention in late 2019, when it suddenly dimmed by 60%. Astronomers later discovered this was caused by a colossal surface eruption, but it raised a thrilling question. Was this a sign of the star's impending doom? Since then, Betelgeuse has kept scientists on their toes. In 2024 alone, it dimmed rapidly, dropping 0.5 magnitudes in mere months. While it's naturally a variable star, these extreme and frequent fluctuations hint that something bigger might be brewing. To grasp why, let's revisit stellar evolution. Massive stars like Betelgeuse, 11 to 12 times heavier than the Sun, burn through their fuel quickly. Having already exhausted their hydrogen, they now fuse heavier elements. Eventually, an iron core forms, which can't sustain fusion. When enough iron accumulates, the star collapses under its own gravity, triggering a supernova. Betelgeuse's erratic dimming and surface disturbances, observed by the Hubble Space Telescope, suggest it may be entering its final phases. For the first time ever, we might be witnessing a star's last act with cutting-edge technology. That said, when astronomers say Betelgeuse could explode any moment, they mean any time between now and the next 100,000 years. Recent research has sharpened our predictions. A 2023 Astrophysical Journal study estimates Betelgeuse might explode within decades based on its core behavior. However, the star's uncertain distance, between 430 and 643 light-years, adds complexity. Here's the fascinating twist. The light we're seeing now departed Betelgeuse centuries ago. The explosion might have already occurred, and we're simply waiting for the light to reach us. When it arrives, the show will be spectacular. Astronomers predict it could glow as bright as the full moon, remain visible for months, and even outshine the daytime sky for weeks. This would become the most brilliant stellar event in recorded history, gradually fading over years. Fortunately, at 400+ light-years away, we're perfectly positioned. Close enough for a great view, but far enough to be safe. A supernova would need to be within 50 to 100 light-years to threaten Earth. We get front-row seats without any risk. For scientists, Betelgeuse's explosion would be an unprecedented opportunity. Modern instruments, from space telescopes to neutrino detectors and gravitational wave observatories, would capture every moment across the entire electromagnetic spectrum. These cosmic explosions aren't just endings, they're creation engines. Supernovae forge heavy elements like gold, platinum, and uranium, scattering them across space to seed future stars, planets, and even life itself. Witnessing Betelgeuse's transformation would give us real-time data on how the universe recycles its materials. The event would revolutionize our understanding of heavy element formation, core collapse mechanics, gravitational wave patterns, neutrino emissions. Other massive stars like Antares and VY Canis Majoris offer valuable comparisons, though they're either too distant or behave differently. The closest modern comparison, SN1987A, occurred 168,000 light-years away, making Betelgeuse's potential explosion an orders of magnitude better opportunity for study. March 14, 2024. Update: astronomers at the American Association of Variable Star Observers, OAVSO, reported Betelgeuse, Orion's famous red supergiant and Earth's closest star of its kind, has dimmed by about 0.5 magnitude since late January. While this variable star naturally fluctuates in brightness, it's now at its faintest in several years. Could this signal another great dimming like the dramatic 2019 to 2020 event? More importantly, might these changes hint at impending instability in this aging stellar giant? Could Betelgeuse be nearing its explosive end? As our nearest potential supernova candidate, located a mere 1,000 light-years away, practically next door in cosmic terms, Betelgeuse's behavior has fascinated scientists since its unusual dimming episode in 2019. A groundbreaking 2023 study suggested we might witness its supernova in just tens of years rather than millennia. This prediction stems from understanding stellar nucleosynthesis, the process fueling stars through atomic fusion. Massive stars like Betelgeuse, weighing 8+ solar masses, progressively fuse heavier elements until forming an iron core. When fusion stops, the star collapses catastrophically, rebounding in a spectacular Type II supernova. For Betelgeuse, currently in its carbon-burning phase, which typically lasts approximately 1,000 years, being near the end could mean explosion is imminent, possibly within decades. But what caused the 2019 dimming? Analysis from Hubble and other telescopes revealed something extraordinary. Betelgeuse experienced a surface mass ejection, SME, ejecting 400 billion times more material than our Sun's typical coronal mass ejections. This unprecedented event tore off a significant portion of the star's visible surface, creating the Great Dimming. While Betelgeuse has since fluctuated in brightness, this extreme behavior suggests we're witnessing a star in its final, unstable stages of life. Rest assured, when Betelgeuse eventually explodes, Earth will be perfectly safe. Scientists estimate a supernova would need to occur within 160 light-years to pose any danger, and Betelgeuse sits comfortably at about 4 times that distance. Instead of doom, we'll be treated to one of nature's most spectacular light shows. For those fortunate enough to witness it, the explosion will create an astonishingly brilliant new star in our night sky. Astronomers are particularly excited. Having a supernova occur so relatively close by offers an unprecedented research opportunity to study a star's explosive death up close. While scientists will be busy with their telescopes, casual stargazers will simply marvel at the celestial fireworks. Though many will miss Orion's distinctive ruby red shoulder once it's gone, the supernova will create a dazzling replacement that may even be visible during daylight hours. Spotting Betelgeuse through the year? Winter evenings. The star dominates January and February skies, rising at sunset. Early March. Appears due south in early evening. Mid-May. Briefly visible in western twilight. Summer months. Travels behind the sun before reappearing as a ghost of summer dawn by mid-July. Early August. Returns to pre-dawn. Eastern skies with Orion with its distinctive orange-red glow. Betelgeuse serves as perfect proof that stars truly come in different colors. Interestingly, while designated Alpha Orionis, it's actually slightly fainter than Orion's blue-white Rigel, Beta Orionis. Currently ranking as the 10th brightest nighttime star overall, 7th brightest for most northern observers, Betelgeuse's eventual supernova will temporarily outshine everything except the moon, before gradually fading from view over months or years. And while Betelgeuse's enormous size and turbulent surface make it difficult to measure precisely, Its relative proximity means we'll witness its death throes in unprecedented detail when the time comes. Not as a threat, but as a breathtaking celestial event where neutrinos will give us our first whisper of the explosion before the light arrives, allowing astronomers to capture every moment of this once-in-civilization spectacle that will briefly outshine the moon before fading into cosmic history, leaving behind only enriched space dust and our deepened understanding of stellar life cycles.